0.89. So we have done this, but today's review day. So unit 3 review, review B, second day of review. All right, so for any question on normal distribution, remember you have to draw a normal curve. For any question on normal distribution, draw a normal curve. That is the first thing you want to do. Any question on normal distribution, the first thing you want to do is to draw a normal curve, shed the area. So that's what I'm going to do now. I'm going to draw a normal curve and I'll share the area. Share the area in question. Okay, so I'll pull back my. So that question says 4 and okay, so I am going to draw the normal curve for number 1. It doesn't look straight, but that's okay. So this is number 1. And they told me that the area is 89% of 0.98. So they give me area inside the normal curve. The line of symmetry of the normal curve is the mean, and the mean takes 0.5. So from here down is 0.5. But the number here is 89%. So I think 89% should be somewhere here on the right hand side. So I'm told to find the area to the left. Of course, the area given to me is area to the left. So that is 0.89. Well, the question says find the z-score. Whenever you're given the area and you're told to find the z-score, you remember that all you want to remember is that this is negative infinity, and your calculator does not understand negative infinity. And this is the case of inverse norm. You can read the chart, but if you know how to use calculator, that would be good too. Inverse norm from your calculator. And then the cumulative area or percentile is 89. This is percentile. This is another way of asking you what is the z-score corresponding to the 89th percentile. What is the z-score corresponding to the 89th percentile? This is another question like that. So the 89th percentile, the mean, and the standard deviation of a standard normal curve. So all you need to do is pull up your calculator and find inverse norm. Check out the corresponding z-score of 89th percentile. So I'm going to turn my calculator on and I will look for distribution. And remember, I'm looking for inverse norm. So inverse norm is number 3. Inverse norm is number 3. And I have 0.89. And the mean of a standard normal is 0. Standard deviation is 1. And I'm going to paste. Okay, so when I hit enter, the z-score corresponding to the 89th percentile is 1.227 approximately. So this z-score here is 1.229, actually 227. I hope you know that why this is the z-score is positive. This z-score is positive because 89th percentile is actually on the right-hand side of the mean. So it's expected that the z-score should be positive. It's expected that the z-score should be positive because 89th percentile is greater than 50th percentile. So it should be on the right-hand side. And so that's that question. That is question number 1. It's not even a difficult question. So remember, you have this kind of question in your test. In 2 days, you will be given area inside the normal curve and you are told to find the percentile. By the way, what if you want to use your chart to find this? You pull up your chart. Let me pull the chart. So there are two ways you can answer this question. You can use your chart or calculator. So I'm going to pull up this chart and look for z-score. So I'm going to find the z-score. This is T distribution. So I'm looking for standard normal curve. So this is standard normal curve. And I'm looking for 0.89 area inside the normal curve. So where do I see 0.89? I can just be looking here. So this is 0.88, 0.88 6. So I'm looking for 0.89. So approximately right here, it is 1.23. 1.23. So to two decimal places, the 89th percentile is 1.23. So remember, you look for the point of intersection. So the point of intersection of the horizontal and the vertical. So 0, 1, 2, 3. This is the 89th percentile. So I am going to read the z-score on the left of that. On the left of that, on the left of this, I have, okay, I have 1.2 on the left, 1.2 on the left, and then in the middle right here, I will trace up and I find the z-score, 1.23 approximately. Okay, so you can use your chart or you can use your calculator. It's quicker to use the calculator anyway. And remember, you are timed. It's a time test, so you do not waste time. You don't want to do it using your calculator and also using the chart. You either choose the chart or calculator. You have to do one. You don't do both. Okay, so you use your chart or your calculator, whichever one you want to use. The important thing is that you have to choose one of them. If I were you, I would use the calculator. Calculator is more accurate. So remember, whenever you're given area inside the normal curve, to calculate the z-score, you're doing inverse num. So you do inverse num and then put in the number like we did in the calculator. You put in the number, 89 is the same as cumulative area or area to the left, the mean of the standard normal, and the standard deviation of a standard normal. Whatever you have is the z-score. The z-score corresponding to the 89th percentile. Okay. Okay, so we have answered that question. Let's go to the next question. We're not following the one by one though. Determine the following. This is about okay. Determine if the following probability experiment represents a binomial experiment. So you are expected to know the properties of binomial experiment. If not, explain why. If the probability experiment is a binomial experiment, state the number of trials. Okay, so I'm told to state the number of trials. An experimental drug is administered 60 randomly selected individuals. So administered to 60 people. In other words, the sample size is 60. Okay, and that's the question though. They asked us if we have a sample size. So with the number of individuals responding favorably recorded. Okay, so the question now says select the correct answer. Fill in the answer box. It says yes, because the number of experiments satisfies all the criteria for a binomial experiment. So we have the sample size. N is equal to 60. That's it. A is the answer. So N is equal to 60 is the answer. So we put 60 here. That's all. N is equal to 60 is the answer because they give us the sample size. Of course, you know, If the sample size is not given to you, it is not binomial. Okay, that's all the question. That's a simple question. So remember, we're not going doing this step by step. So we have answered question on binomial. Let's quickly answer one question on area under the normal curve and one question each. And after that, we answer another question on binomial distribution. Okay, what is the area under the standard normal curve? So before I do that, I want to move this and then clean up the board. So I'm going to clean up this board. Some cleaning right here. Okay, and then this question says, let's start from A, the area to the left. So anytime you are told to find the area to the left, first of all, it's a normal curve question. The first thing I want to do is to draw a normal curve. So again, I draw a normal curve because it's a normal curve question. Draw a normal curve. Doesn't have to be perfect. Like mine is not perfect. The center is the mean, and mean contains 50% of the data. Okay, but this time I'm told that the Z is the area inside the normal curve is 58%. So 58% is narrowly on the right hand side. And I'm told to find area to the left again. Find the area to the left. Actually, I am given the area to the left of Z. Okay, is given. All right, so the question should be asking me find the Z score. Determine the area, determine the area under the standard normal curve that lies to the left of Z. So actually, this is Z. So I'm going to clean that. This is supposed to be Z, not area. So I want to make sure that we answer the question we asked it. So I'm going to redraw the normal curve. So I redraw a normal curve, and they told me that the Z score is 39%, 0.39. And because 0.39 is not up to 5, so I am just going to write 0.39 here. Z is equal to 0.39. I made a sketch, 0.39, because it's not up to 1, it's not up to 50. Since it's not up to 50, I'm expecting Z to be negative, because any Z value on the left-hand side of the normal curve is negative. So at this point, I will calculate the percentile. So this is Z. So now I want you to know that I'm given Z. Since I'm given Z, I am looking for the area inside the normal curve. So how do I find that? The normal CDF. See, I am going to normal cumulative density function. The left-hand side is negative infinity. So negative 1e to power 99. What am I looking for? I am looking for the area, the shaded area. And that shaded area extended to negative infinity. And I'm told to find the area. And I know that 0.39 is greater than negative infinity. So the lower bound is negative infinity, upper bound is 0.39. The mean of a standard normal is 0, standard deviation is 1. So let's calculate. So we're going to calculate that now using our calculator. You can do it by hand, I mean with chart. So whichever method you want to use, that's fine with me. Okay, so now I want to calculate the area inside the normal curve, which is the opposite of what we did before. This is the opposite. So this is number 2. And the area to the left, I have to put in negative 1e to power 99. So let me do that again. Negative 1e. How do I find e? Second comma to power 99. the upper bound, because 0.39 is greater than, so 0.39. And then the mean is 0, standard deviation is 1. So I'm going to paste. Whatever I have now is the area inside that normal curve. Therefore, the area inside the normal curve between negative infinity and z equal to 0.39 is 0.6517, approximately 0.652. So this area is 0.652. Of course, you know that area cannot be negative. In other words, the percentile corresponding to z equal to 0.39 is 65.2%. In other words, the z-score covers 65th percentile. Okay, so that is the answer for the question. Remember, the most important thing is that you should know when the question is area inside the normal curve and when the question is asking you to calculate the z-score. So when you're given the area inside the normal curve, then you're calculating the z-score. But if you're given the z-score, you are calculating the area inside the normal curve. Okay. All right. So we are done with this number, and we're not going to continue that because this is review. We want to make sure we touch all the probabilities we did. We did binomial probability distribution. We did discrete probability distribution. We did normal probability distribution, and we also did central limit theorem. So we want to make sure we touch all of them. So for number 5, question number 5 is actually, question number 5 is talking about normal probability distribution. I mean, binomial probability distribution. So let's go there. Let's go to question number 5. So this question number 5 says, a binomial probability experiment is conducted. So even if you're not told it's binomial, there are questions you see, you know what they are. Can you identify this question to be a binomial distribution question if you're not told that it is binomial? If it has a yes, when it has all the properties of binomial distribution, then it is binomial. So a binomial probability distribution is conducted with the given parameters. Compute the probability of n successes in the n independent trials. Okay. So what I'm going to do is, I already know what I'm given, so I'm going to clean up some part of this, about to clean up some of them so I can use this to answer the question. So this is the binomial distribution question. And first of all, I'm told that the sample size, it is binomial. Everything about it is given to me. Sample size is 12. Probability of success is 10% of 0.1. The random variables is x, and it is x is less than or equal to 4. So I'm accumulating to the left. And by the way, what does this all mean? It means calculate the probability of 0, calculate the probability of 1, calculate the probability of 2, calculate the probability of 3, and calculate the probability of 4, and add them all together. I hope you remember that probability of 0 is 12 combination 0, success to power 0, failure to power 12 minus 0, and so on. P1 is 12 combination 1, success to power 1, failure to power 12 minus 1, which is 11. Okay, so you know, I just want to remind you because it's been about 2 weeks and we went on spring break. Okay, but I don't want to do them individually though. This is how to do them individually. I want to do all of them together. So what I'm going to do now is cumulate all the probabilities. I'm not doing individual. I wasn't asked to do individual probabilities. If I am asked to do individual probabilities, then I will go and do it. But for this time, I am not asked to do individual probabilities. Okay, so I am going to be doing cumulative density function. So I'm going to do binomial cumulative density CDF, cumulative density function. Why? Because I'm cumulating from 4 to 0. So the question, the argument is NPR, where N is sample size, P is the probability of success, and X, which is the random variable. In this particular case, it is 4, because I'm going to accumulate from 4 down. So it is 4. If it is only less than 4, then our 4 will not be there. But right now, 4 is included. It's a closed end. Okay. Then the next thing I want to do is get my calculator, put all these things in my calculator. And then I turn it on, and I'm clear. And say binomial CDF, so second distribution again. But this time I'm looking for binomial CDF. So number 2, I'm accumulating. So the question, actually, this is, I'm supposed to be looking for binomial, not normal. Okay, binomial CDF. So I'm going to be looking for binomial CDF. Now I found it, it's B. So I found binomial CDF, and it's asking me, what is the sample size? What is the number of trials? And the number of trials is 12. And the next thing it's asking me is, what is the probability of success? The probability of success is 0.1. And the next thing it's asking me is, what is the random variable? The random variable is 4. Then do you want me to calculate? Yes, I said calculate. So when I hit enter, ask me, is that what you really want? Yes. When I hit enter, it gives me that the probability of success is 99.67%. The probability that he can accumulate from 0 to 4, in other words, from P0 plus P1 plus P2 plus P3 plus P4 is equal to 99.57%. So that is the probability. 99.57% is that probability that I'm told to accumulate. Okay, so this is one example on binomial distribution. Remember that this question can be area to the right. It can be area between. So it depends on what the question is. You need to answer the question. Okay, so we have done one example of binomial distribution. We want to make sure we touch each and every one of them. We have already done number 6, area under the standard normal curve. We want to make sure we touch all the other. Okay, so look at number 7. Number 7 is a question on discrete probability distribution. Remember, we had 4 distributions. The first one is discrete probability distribution. The second one is binomial probability distribution. They're all probability distribution. The third one is normal probability distribution. The fourth one is the central limit theorem. So all the questions in these 4 distributions are in unit 4, in unit 3 test. That's why we want to make sure we review all the sections. Okay, so number 7 is a question on discrete probability distribution. All right, so the following data represents the number of games played in each series of an annual tournament from 1923 to 1920 to 19. Complete parts A through D. Okay, complete parts A through D. All right. All right, so I'm just going to clean this part and then we go to the answer that question. Okay, that question is on discrete probability distribution. Okay, so what did they tell me to complete? Actually, they give me the information, but they want me to extend the table. You know what? I'm going to put this information I will put the information um, in my whiteboard. So that will help me to, okay, so and I want to put this vertical, change the horizontal table, the horizontal frequency distribution. I want to change it to vertical. Okay, so what I'm going to do now is change the horizontal table to vertical. So X and frequency is Y, and 4 to 19, 5 to 20, 6 to 20, 7 to 37. And by the way, what is it says the following data represents the number of games. So this is about games. Okay, so the next thing I want to do is find the total. What is the total frequency? Okay, so I can add them up. 20 plus 20 is 40, plus 19 is 59. I can just call it 60. 60 plus 36 will give me approximately 96. Approximately 96. So the total frequency is 96. Okay, so the next column I can have is relative frequency or probability. I want you to remember that relative frequency is something as probability of X. And probability of X is always the frequency of X divided by total frequency. Probability of X is the frequency of X divided by total frequency. Frequency of 5 divided by total frequency. Frequency of 6 divided by total frequency. Frequency of 7 divided by total frequency. Okay, so we have okay, and then I can actually make this table. So the question is asking me, I want to reduce the relative frequency of probability. I want to reduce it to decimal, so that way I can answer the questions. I will be able to plot the points. Why am I changing it? Because the vertical axis is in decimal. So remember that the relative frequency of probability should actually be the vertical axis. And I have to look at the options given to me. Are they in whole number or fractions? They're in fractions. And so that is why I want to change the relative frequency to fractions. Okay, so I'll get my calculator, put my calculator up right here. And then I will change the relative frequency to fraction. So I'm going to clear. So the first one is 19 over 96. 19 divided by 96. I'm going to get it to 2 decimal places. So 1 point, well, I'll make it to 3 decimal places. But if I make it to 2 decimal places, that will help a lot. Make it approximately 0.2. 0.2. Let me write probability of X. Okay, let's go to the next one. 20 divided by 96. And I have 0.21, so 0.21. The next one is the same, so it's going to be 0.21 again. And the next one is 39 here, 39 divided by, so 39 divided by 96. When I hit enter, I have 0.41. So I have 0.41. I can make a sketch or compare the sketch I have. So it seems like the first bar should be the smallest bar. Okay, and the last bar should be the highest bar. So I can go ahead and start picking up. I can go ahead and I want to look at which option resembles, for sure, sure, A is wrong because the first bar is the shortest bar. This looks good, but we want to make sure, what is it? 0.2. So is this 0.2? No. So B is wrong because it's actually supposed to be 0.2. Okay, well, this looks good because it's 0.2, almost 0.21, 0.2, and then this is 0.4. So C looks good. Well, let's look at how D is. Well, it's not 0.1. It is not 0.1. So the probability column says 0.2, 0.21, 0.2 again. That means that the correct answer is C. So I used my probability distribution. First of all, I'm told to compute the probability distribution. So we have answered this question. We have answered this question right here. We answered the question. And then they wanted us to pick the correct answer. We picked the correct answer, which is C. And then the next thing they're going to ask us is find the mean. Find the mean and standard deviation. See, find the mean and find the standard deviation. So you do one variable start. So go to your calculator and put in the numbers. And I'm going to put the numbers the way they are. So we are doing number. Okay, so I'm going to put my calculator up because I really don't want to use. Okay, so I'm clear. I am going to go to STAT. I'm putting the data. I'm going to put the data in the way it is. Okay, so I'm going to clear L4. I don't need L4. I don't need L3. L4, clear, enter. L3, clear, enter. L2, clear, enter. L1, I don't need any of these. Clear, enter. All right, so in my L1, I will put in the random variables, and that is 4, 5, 6, 7. And then in my L2, I will put in the probability. And that the first one is 19 over 96. 19 divided by 96. Hit enter because I want to have decimal points. The next one is 20 divided by 96. The next one is 20 divided by 96 again. And the third one, or the last one, is 37 divided by 96. So when I hit enter, that is what I have. That is all the probabilities. If I add them up, I should be getting 1, but I don't need to add them up. Okay, so I'm told to find the mean of this probability distribution and standard deviation. All I have to do is go to stat, arrow to calc, do one variable stat, and then I'll tell my calculator where my L1 is. My L1 is the random variable, and my L2 is the frequency or probability, and calculate. Okay, so I am told to find the mean. So I already found the mean. Therefore, the mean is 5.78 to 2 decimal places, and the standard deviation is 1.16 to 2 decimal places. So let me see, where did that tell me to? How many decimal points? So the round, okay, to 1 decimal point. Okay, if my answer should be to 1 decimal point, so I might as well. Anyway, so everybody knows how to change the answer to decimal point. And so that example is example for discrete probability distribution. The next example we want to do is an example on um, central limit theorem. We did it last week, 2 weeks ago, before we got on spring break, but I want to make sure we do it again. Okay, so number 8, central limit theorem. Okay, so the question here is asking us, so I'm going to let me clean some parts of this whiteboard. So the question here is, find the mu x bar, which is the mean of central limit theorem, and the standard error. That's all. So all we need to do is make sure we state the central limit theorem indirectly. So the mean of means, which is the central limit theorem, is the same as the mean of the original data. The mean of means, mu x bar, is equal to the mean of the original data. And so that mean is 65. And the standard error, which is a standard deviation of the mean distribution, is equal to standard deviation of the original data divided by square root of sample size. So I'm going to find all these things in my calculator. And then the given standard deviation is 15, and the given sample size is 23. So everybody can do this. You get out your calculator and find the, it says round to 3 decimal places. So you round to 3 decimal places. And then that's it. It's not really difficult, and we have done it several times. Let's go to section number 9. Without doing any computation, put the following in order from least to greatest. Why would they ask you to put it in order from least to greatest? Because the higher the sample size, the more normal the data is. So if it's the one with the smaller sample size, then it's going to be small. But anyway, you will have to put them in. It says, without doing any calculation, put the following in order from least to greatest, assuming the population is normally distributed. I hope you know that this question is a question on central limit theorem. This question, but because if it's a question on central limit theorem, they are asking you to find the area between the random variables. You're looking for area between the random variables. So let's start. You can do it by that said you, but what you want to do is calculate the smaller. This one should be smaller, and so on. But anyway, let's do some calculations before we make a conclusion. So let's do some calculations before we make a conclusion. For the first one, it is area between. So you draw a normal curve. So I am going to quickly draw. I don't want to, we have a few minutes to go, so I will need to give you time to ask questions. Second distribution, it is area between. So I am going to select cumulative, and then the lower bound for A is 180. The upper bound for A is 220. And I'm not told to convert them to standardize them, so I don't have to worry about that. The sample size is the reason why they give me sample size though is to calculate the standard error. All right, so the mean, I don't know if they give me the mean. Yeah, the mean is 200. They give us the mean, and then the standard error. Everybody have to be careful right here. The standard error is the standard deviation divided by the square root of sample size. So the standard deviation is 20. Actually, standard deviation is 25. Then I'm going to divide it by square root of sample size for A. Okay, so square root, second square root of 40. All right, so I'm dividing by a big number. And the next thing now, I'm going to calculate what is that area. And that area is approximately 100.999 something. So the area is almost 100. I'm going to leave that there and I'll calculate the other one. So I'm going to just say second enter. Why? Because the numbers are the same, almost the same. So 180 to, okay, the first one is 180. Let me just make sure. Okay. I'm going to arrow to the, so that I want to make sure that I put in the right number. Okay. Well, just know that the only thing we are changing here is 20. Sample size changed from 40 to 20. So, in other words, what happens when the sample size changes? So I'm gonna put 20 there. Okay, so I'm about to evaluate this one. I want to see the difference between double. You see, we doubled, we one halved 40 divided by 2. So we put the sample size in 2. So what happened here? Almost the same. In other words, it is greater when the sample size is higher. Okay, but why did they not give us anything here? They did not give us sample size. In other words, they want to say that. So the important thing is they want us to arrow them in order, put them in order from the least to greatest. So the least is the one. Let's check what they did. Check what they did. Number 9. This is one of those questions that confuse people, but okay, so CBD, CBS. So C is the least followed by B and so on. Okay. That's number 9, and we have answered questions on central limit theorem. So the next question is going to be, see, this is also on central limit theorem, a standard normal curve. So we have done a standard normal curve. Well, this question looks easy, but I don't want people to miss it. Determine whether the distribution is discrete. Is this distribution discrete? How do you know? Is there anything you need to know? All you need to know are the properties of normal distribution. If you're given a distribution to see if it is discrete, all you need to do is find the probabilities of each random variable. After that, you add them all together. If all the probabilities sum up to 1, then it is a discrete random variable, provided there is no negative probability. So this one looks good for now. So let's see. There is no negative probability, but let's add them up and see. Let's add all the probabilities up. So I'm going to clear, and I have 0.21 plus 0.35 plus 0.14 plus 0.08 plus 0.22. Okay, I want to see what happened. Yeah, so the sum of all the probabilities is equal to 1. Therefore, it actually obeys the probability rule. And since the sum of all the probabilities is equal to 1, yes, this is a probability distribution. I cannot see any negative probability. Therefore, it's a probability distribution.